Hey everybody, so I have gotten a lot of questions about solubility and concentration and how to calculate concentration. So I am going to go through kind of a brief overview of what exactly concentration, what that means. And then I'll also include a little portion on IXL L.1, the compare concentrations of solutions. And I'll work out the problem, kind of do the math portion of it. I am going to write out, while I'm talking, I'm going to write out on some paper that I have in front of me, and I'll kind of talk through it out loud. And then when I'm done recording this presentation, I'll insert what I have written down on my paper. I'll take a picture of it and insert it into the slideshow that you'll be able to view. Okay, so on the screen right now, you are looking at a Kool-Aid packet, and you have three boxes. One is kind of a bright red box with a thumbs up next to it. Then there's kind of a pink box with a thumbs down next to it, and then kind of a maroon, I hate to say crimson, War Eagle, but this kind of maroon box right here with a thumbs down sign as well. Okay, so what I'm trying to show you with this is when you make Kool-Aid or lemonade, Gatorade, anything with powder and water, you want to follow the directions on the back. Why do you want to follow the directions on the back? Well, you want your drink to taste good. So if you follow the directions correctly, hopefully your Kool-Aid ends up looking like this top box with the thumbs up next to it, that bright red, okay? Now, let's pretend, let's look at this middle box, okay, kind of the pink one. Why do you think, what would you have to do in order to make your Kool-Aid look a little less red? Okay, think about what would happen if you put ice into your drink and left your drink outside and the sun melted your ice. What would happen? So the ice would melt and your drink would be kind of watery, right? It would be gross. That's why I have the thumbs down next to it. So it's pink because there's a little more water in there than when it started, right? When the ice was frozen. So your drink is now diluted. It tastes gross. It's way too watery. Okay, so there is more solvent, water, in there than there was to begin with. So that's why I have a thumbs down. It's gross. Okay. Now this maroon color right here, think about what you'd need to do in order to make your drink darker. Okay, so let's pretend you made a perfect batch of Kool-Aid, like the box on the top. But maybe little brother, little sister comes around when no one's watching and dumps an extra packet or 2 or 3 of Kool-Aid into your perfect batch. Well, when you look at it, it's going to look a little darker. And when you taste it, it is going to be very sugary. So it's going to be probably kind of gross. It's going to be so sweet that it's gross. Okay, so that's why we have a thumbs down next to it. Now, think about this, okay? Let's pretend either one of these situations, okay? Let's keep going with this where it's way too sweet. So you have way too much solute in there. Let's pretend that you don't have any more packets left, so you can't really restart. Think about how you could problem solve in order to turn this nasty, way too sweet Kool-Aid back to a perfect batch. What would you have to do? You could add more water, right? So you might need a bigger pitcher. You'll probably need either a bigger pitcher or multiple pitchers, but you could add a lot more water in order to make it taste good again. Okay, think about too this, our other example with where it was way too watery. What could you do in order to make it taste good again? You could just add a little more powder, okay, to make it that good bright red color that we love. Okay, so that's kind of an overview on solubility and concentration. and what diluted or supersaturated means. And one thing that I didn't include on this supersaturated solution, so a lot of times too, not only will it be that dark red color, but there will also be some of the sugar at the very bottom, because the water, that solvent, can no longer dissolve that solute. Okay, now you could theoretically heat up this nasty, way too sweet solution in order to make the particles dissolve, so you wouldn't at least have as many particles of sugar at the bottom, but it would still not taste very good. Okay, so let's move on to the IXL. Okay, so we're looking at stage 1 to begin with. Okay, so my example, I know these kind of look purple, but I believe IXL refers to this color as pink. So in solution A, it tells you that you have 35 milliliters of the solvent. And in solution B, you also have 35 milliliters of the solvent, of the water or the liquid. So I believe on stage 1, the solvent volume stays the same on every problem. What changes is the solute, so the number of these dots or circles. Okay, so in solution A, if we count the number of dots, 1, 2, 3, 4, 5 pink dots in A, and then in solution B, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you can kind of think about, I believe the question is asking you to choose which one has a higher concentration. So think about it almost asking you which one tastes sweeter. And if we pretend that the solvent is water and the solute, these dots, these pink dots, are like scoops of pink lemonade or something. So let's pretend you have the same amount of water in 2 different cups, but you add 5 little scoops of pink lemonade into the first cup, and you add 8 scoops of the pink lemonade in the second cup. Which one has a higher concentration? Which one tastes sweeter? Just by looking at this and counting the dots, we know that solution B is going to taste sweeter. It has a higher concentration. Okay? So for stage A, there's not really much, math to do besides counting. So let's move to the second example. So the second example, the solvent volume is the same. Now, so we need to figure out which one has a higher concentration. Well, right off the bat, you should be able to look at it and tell that there are 3 scoops of pink lemonade in the left, and there's 3 scoops of pink lemonade on the right. So it almost looks like these 2 solutions are identical, and that's because their concentration is identical. So for this, both of these, they have the same concentration. Okay, so that one was pretty easy. Just kind of look and tell, but just make sure you're paying attention to that solvent volume. That'll play into some stuff in stage 2 and 3 that we'll look at in a second. So next, we're looking at the third example for stage 1. Again, our solvent volume is the same. What looks different? The amount of scoops of blue Powerade powder. Okay, so in solution A, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blue dots. We have 1, 2, 3, 4, 5, 6, 7 blue dots for B. So which one is going to taste sweeter? Solution A, the one where you added more blue Powerade. We're going to move on to stage 2. So stage 2, we have 2 solutions here. And you want to look at the solvent volume first. Okay, I want to point this out that on solution A, we have 40 milliliters of solvent, but solution B, we have 50 milliliters. Okay, so make sure you're paying attention to the solvent volume first, especially for stage 2. Okay, so here's what we're going to do first. On my paper, I'm going to have 2 different columns, column A, column B. So that's for solution A and solution B. The first thing we want to write is the amount of solute that we have. So we need to count the number of dots. Okay, so in A, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 dots in solution A, or 12 scoops of blue Powerade, if you want to think about it like that. And in B, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we also have 12 scoops. But think about this. We're going to get to the math part, but just think about this, okay? So if you have the same amount of sugar or blue Powerade in 2 cups, but you add more water to cup B, which one is going to taste a little more watery? Which one is going to taste sweeter? Okay, so solution A is going to taste sweeter or more concentrated because there's not as much water. Now, this is one way you could also look at it, and I don't want you to just right off the bat do it this way each time because our eyes can play tricks on us. But if you look at A versus B, the solution A, the solute looks a little more crowded, whereas in solution B, these blue dots have a little bit of more room to kind of move around. So you can kind of think about it that way. But sometimes, I don't want you to just go off of what it looks like. Sometimes we will have to do the math. So I'll finish out the math for this problem. So we said solution A has 12 dots. Solution B has 12 dots as well. Solution A has 40 milliliters of water. Solution B has 50. So what I'm doing on my paper for solution A, I have 12 divided by 40 milliliters. When I plug that into my calculator, 12 divided by 40, we get 0.3. Okay. For B, we have 12 dots divided by 50 milliliters. 12 divided by 50 equals 0.24. So whichever one has the greater value or the greater number is going to be more concentrated. Okay, so we have figured out, I should say, that solution A is more concentrated. Okay, so I'm going to box that answer in. Okay, let's move on to the second question for stage 2. So if you look, this one is kind of hard to just look at and tell which one's more crowded because the amount of solvent is so different in these. So this one, especially questions like this, I would really suggest working out. So for this, I'll have my 2 columns. Let's focus on A first. So I'm going to count the number of dots, 1, 2. So I have 2 divided by the amount of solvent, which is 20 milliliters. I'm going to plug that into my calculator. 2 divided by 20 equals 0.1. And then for B, count the number of dots, 1, 2, 3, 4, 5, and divide it by the amount of solvent. So we have 50 milliliters for B. So I'm going to plug that into my calculator. I have 5 divided by 50 equals 0.1. Okay, so notice here that the numbers that we got are the same. That's because the concentration is equal. Even though we have different amount of solvent and solute, they're equal. So every 1 scoop of sugar, this person added 10 milliliters. Okay, so it is equal. The concentration is equal. Okay, so these drinks, if you took a sip of them each, they would taste the same. Okay, that's kind of what we're talking about. Okay, so for this, the concentration is the same. Now here's stage 3. This one gets a little tricky. And I have 2 examples for this one. So for this, I believe IXL has kind of thrown in a distractor. So it asks you either, what's the which one has a higher concentration of green or purple. So it depends on which one it's asking you. I am going to look at let's do purple for this, okay? So for solution A, let's count how many purple dots we have. Solution A, we have 1 purple dot, and our solvent volume is 30 milliliters. So in my calculator, I'm going to do 1 divided by 30, and we get 0.03 repeating. And for B, the amount of purple dots, 1, 2, 3, 4 purple dots, divided by how much solvent? 25 milliliters. So if I do 4 divided by 25, we get 0.16. So in solution B, the amount of purple dots, there is a higher concentration of purple dots in solution B. Okay. Now, for this same problem, I'm going to work out the concentration for the green dots, just so you have a little more practice, so you can see another example. So the same problem, I'm just kind of switching to the green dots now. Okay, solution A, we have 3 green dots. Still, obviously, have 30 milliliters of water. Plug it into my calculator. 3 divided by 30. The answer is 0.1. For solution B, the green dots, we have 1 green dot divided by 25 milliliters of water. So 1 divided by 25 is 0.04. So in this example, there is a higher concentration of purple dots in solution B, but there's a higher concentration of green dots in solution A. Okay, so it just kind of depends on what IXL is asking you. Pay attention to which color dots they're asking about. Okay, here's our last example. Again, we have 2 different color dots. I'm going to start with the pink dots. Okay, so solution A has 3 pink dots and 20 milliliters of water. Plug that into my calculator. 3 divided by 20, I get 0.15. Solution B, we have 2 dots divided by 40 milliliters of water. 2 divided by 40 equals 0.05. So in solution A, we have a higher concentration of pink dots. Okay, now I'm going to move on to just the green dots for this same problem. Again, it just depends on what IXL is asking you. You're not going to have to calculate both. It's going to ask you about one in particular, and the other color is kind of thrown in there as a distractor. So for the green dots in solution A, we have 1, and there's 20 milliliters of water. So my calculator, 1 divided by 20 equals 0.05. The number of green dots in B, we have 2, and there's 40 milliliters of water. 2 divided by 40 equals 0.05. So for this, it's kind of interesting. I don't think that you can necessarily look at this and tell right off the bat without doing math. But there's the same concentration of green dots in both solutions. So it depends on what IXL is asking you. Pay attention to the question that it's asking. And please reach out if you have any other questions. Hopefully this helped a lot. Thanks.